Now let's look at another form of sequence, which is a geometric progression, GP. This is more or less similar like AP. However, there we used to add terms to get the next forthcoming term. Here we will be needed to multiply a certain ratio, which we call it as the ratio, to get the next term. For example, an example of a geometric progression sequence would be 2, 4, 8, 16, 32, and so on. So here if we look at the common ratio between all these terms, it comes out to be 2. And how do we get it? We get it 16 by 8. We get it by dividing two consecutive terms and we get the common ratio. That is exactly what has been mentioned here. In AP we used to mention it as common difference. Here it is a common ratio, and again 2 is the first term, so it is notated as A, and the nth term of a GP would be A into r to the power n minus 1. Let us prove this in this sequence. Let's take 16, which is the fourth term. So if we were to find the fourth term, it would have be A r to the power n minus 1. A is 2, r is 2, n is 4, so it would be 3, 2 into 8, which we get as 16. So yes, definitely this formula as well works. You also need to remember this formula, an important formula for you to solve questions of GP. Let us take an example to understand that formula's concept a bit more. Consider a GP if the ratio of third term to first term is 25. So let us write down what has been given to us. The third term to first term is 25. Then calculate the ratio of ninth term to fifth term. This is what we have to calculate. So let us use the formula that was given to us. A r to the power n minus 1 upon A r to the power n minus 1 is equal to 25. This is for the T3 and this is for T1. And since we know T1, since this is the first term, if we put n is equals to 1, we would get A, as we know the value of A. So this would become A r square upon A, and A gets cancelled. R square is equal to 25, so R is equal to 5. So we've got the common ratio here. Now let's find out what we have been asked in the question. T9, this would become A r to the power 8 upon A r to the power 4. A and A would get cancelled out, r to the power 4 would cancel out, and we would get the answer to be r to the power 4, which is equal to 5 to the power 4, and yes, this is our answer. Now again, most of the things that we studied in AP would be similar for GP as well. For example, as we had mentioned there as well, the nth term from the end. Again, the same formula would be used to calculate this thing, which would become n minus capital N plus 1, 1th term from start. And since in AP we had studied that the sum would be given in the question. However, when a GP is given, product is generally given. That is why the way of assuming terms is A by R, A and AR, because so that whenever we multiply these terms, our terms get cancelled and we get just one term in our equation. So it becomes easier for us to solve questions. In similar way, when 4 terms we need to assume, we take the common ratio to be R square. Now again, a few important properties of GP that you need to remember. In AP we had studied that the sum of terms equidistant from beginning and end is same. Here we are looking that the product of terms equidistant from beginning and end are same. That means A1 into AN would be equal to A2 into AN minus 1, and so on. This would be equal to the square of the middle term. square. Another important property, if ABC are in GP, then KA, KB, KC are also in GP, and the common ratio R dash of the new GP formed would remain the same. There would be no changes in the common ratio. And then another property, if we were to take K to the power of each and every term, then still that sequence would remain in an GP. And if we were to find out the common ratio of this, it would be A2 by A1 whole to the power K, which we can refer as R to the power K. That means the new common ratio for such type of sequence would become R to the power K.